So we've just got two more multiplies to go, and I have this variant of something we saw earlier. We earlier saw the integer 128 and a hard-coded constant value. This is the same thing, but we're taking in input from A to L, which is ASCII string to long. Now a long is a 32-bit value, not a 64-bit value. So when we compile that with size minimization, we get this very simple code with only a single mul-h as a new assembly instruction and a mul. So what's the mul-h? That is multiply, keeping the high x-lang, and it is intended to be used for signed times signed, as opposed to the mul-hu for unsigned times unsigned that we saw before. So take the signed rs1 times the signed rs2 and store the high x-lang into register destination. And that's exactly what that says. And mul-h, as mentioned, is supposed to be used when both arguments are signed. So going back to this example from before, hex 20 times hex 1 and 15 zeros equals 2 for the upper 64 bits, and do the multiply to capture the lower 64 bits. Hex 20 times hex 1 and all zeros equals zeros in the lower. So we know that hex 20 times 1 and 15 zeros is going to be 2 and 16 zeros. So it's just that simple, but you want to step through the assembly anyways so that you can understand why the compiler could get away with doing such a small amount of code compared to the extremely large amount of code we saw before. So I'll let you make your guesses about why that could be after you look at the code and step through the assembly.